All right, so today we're diving into a story that's a real clash of eras. We're talking about taking this heavy, old-school mechanical machine and trying to make it speak the language of the future. You guessed it, code. It all kicked off with this one simple, kind of wild question. What if you tried coding not on your sleek, modern keyboard, but on a real, clunky, honest-to-goodness typewriter? I mean, could that even work?
Okay, so let's get into it. This whole thing, it wasn't just about a cool gimmick. No, it was a genuine challenge, right? The question was, could you actually take a purely mechanical object from like decades ago and turn it into a real functional tool for our digital world?
And where did this idea come from? Well, where else? The internet, of course. After going down one of those classic rabbit holes, filled with retro computing forums and maker blogs, it turned out that converting a vintage typewriter into a USB keyboard, well, it wasn't just a crazy idea. People had actually done it. And that was it. The gauntlet was thrown down, challenge accepted.
So inspiration is one thing, but actually doing it, that's a whole other story. Which brings us to the really messy part, the often, let's be honest, frustrating part, the engineering nightmare of trying to turn a 1960s machine into a modern programming tool.
So what exactly do you need for a project like this? Well, the shopping list is pretty great. First up, a 1960s Olympia typewriter, the kind that's heavy, beautiful, and built like a tank. Then you need the brains of the operation, an Arduino Leonardo, which is perfect because it can pretend to be a keyboard. Throw in a bunch of wires, sensors, a soldering iron, and, my personal favorite, a dangerous level of optimism. Trust me, you're going to need that last one.
Now, on paper, the plan seemed almost laughably simple. Step 1, press a key. Step 2, a sensor detects that press. Step 3, the Arduino sends that letter to the computer. Easy peasy, right?
Yeah, no. Not even close. See, here's the massive catch. Typewriters are 100% mechanical. There are no circuits, nothing. So that simple plan of just detecting a key press, it suddenly meant having to wire up a sensor to every single key lever. It turned a simple software idea into a total hardware nightmare.
And just how much of a nightmare are we talking about? We're talking 6 hours. 6 intense hours. Hours of cursing, testing, probably a few minor burns from the soldering iron, all just to get a barely working prototype off the ground.
And what did all that effort get? Version 1.0, and let me tell you, it was a mess. It had this massive input lag, like half the keys just didn't register, and trying to type a single command felt like it took forever. But it worked. Kinda. And you know what? With a project this crazy, even a kinda feels like a huge win. All right, so the Frankenstein's monster of keyboards was officially alive. Now it was time for the real test, the moment of truth. Could this thing actually do the one job it was built for? Could it write a real line of code? And here it is, the very first line of code ever successfully typed on this typewriter keyboard hybrid. And it's just perfect. You can almost feel the mix of triumph, relief, and just pure absurdity in this one little statement. Console.log, this is ridiculous. But this is where the story gets really interesting, where it takes a totally unexpected turn. See, the engineering challenge was basically over, but the actual experience of using this thing, that was just getting started. It created this huge vibe shift where the machine's limitations, well, they changed everything. So what was it really like to code on this thing? Well, the reality was brutal. First off, every single key press is loud. Then you realize, oh wait, there's no backspace, no arrow keys. And forget about Command Z, that safety net is gone. Make one tiny typo. You have to scrap the whole line and start all over again, from scratch.
And these limitations, they weren't just annoying, They fundamentally changed the entire process of coding. The machine literally forced a new way of thinking, a total break from how we normally work. The only way to get anything done was to just slow down and actually think before every single key you pressed.
I mean, just think about that contrast for a second. With the modern keyboard, everything's about speed, right? You've got autocomplete, AI helping you out, instant debugging. The typewriter? It's the exact opposite. It forces you to think first, to plan ahead, to make every single line deliberate. And all of a sudden, what looked like disadvantages were actually features. Features that forced you to be mindful.
As the creator put it, it felt less like coding and more like writing a letter in 1972. It just completely transformed the work from a purely technical task into something way more personal and methodical.
So after all that work, after all the soldering and the frustration, what's the big takeaway? What did this wonderfully weird experiment actually teach us? Let's wrap this up and find out.
You see, this whole project, it was never really about efficiency. It couldn't be. It was about something else entirely. It was about rediscovering an appreciation for the craft itself, feeling the weight and the permanence of every single line of code you write.
This whole experience actually gave birth to a new term, deliberate coding. And it's exactly what it sounds like. It's the act of slowing down, planning your moves, and writing code like you really mean it. And the funny thing is, the irony of it all, is that being forced to be so deliberate, it actually makes you write better code with fewer mistakes.
So after everything we've heard, the big question is, would they do it all over again?
And the answer? It's just a perfect mix of honesty and humor. Maybe. For the aesthetic. And I kind of love that. It's a great reminder that sometimes the whole point of a project isn't about being practical. It's about the experience, the style, the story. And really, that kind of brings us to the heart of this whole thing, doesn't it? Sometimes going backwards actually teaches you more than just rushing forward. In a world that's so obsessed with making everything faster and more efficient, there's something really valuable about just slowing down.
So that leaves me with a question for you. What weird experiment, what strange mashup of old and new tech should we dive into next? Let us know. Thanks for joining us for this explainer.